There's always benefit to exposition. Section I'm looking at right now. Let's just chat. How about it? How about we just chat, okay? Let's just chat. I don't know if I want to give that advice. This advice maybe was more applicable for like 15 years ago, but maybe things have changed a lot because I really haven't looked into it in any depth. So if you have ace 2 and you've seen 3 cards so far, out of which none of which are ace and 2, what is the probability you're going to end with a pair given you're playing with 4 other people? Well, so this is one of those things that's sometimes confusing. It actually does not matter how many other people you're playing with. That's not a relevant factor here because you don't know what cards they're holding. I mean, you can make some inferences perhaps based upon their betting pattern and things like that. You can estimate what the probability is that they hold themselves an ace or a 2. That would have some bearing on the probability of making a pair. But your question is, if you were to stick it out to the end and see the turn and the river card, what's the probability that you'd make a pair? Well, there are 7. No, excuse me. There are how many? There are 3 plus 3. There are 6 aces and 2s left in the deck. How many cards are in the deck? There are, let's see, 47 cards, right, in the deck. The number of possible ways of dealing out the 2 cards in total is a number called 47 choose 2. This is the total number of turns and river cards, right? And how many of this 47 choose 2 give you a pair or better? Well, you need to be able to have drawn at least one of those aces or 2s, right? So how many ways can you draw at least one ace or 2? Well, like there are 6 possible cards that you can use to make a pair. You want to be drawing at least one of them, right? So that's 6 choose 1, and then the other card can be literally anything else. So the other card can be 46 choose 1, right? So then you do this computation of this is of course just 6 times 46, right? And then you divide this by, so this is the number of ways of pairing. And then to get the probability, isn't the deck going to be small? Well, so the thing is you don't know what the values of those cards are. Like they could be, unless you, again, have made some inferences, there could be literally anything in those cards. So you might as well just think of those other hands as being part of the deck, right? Like if you don't know that anybody else is holding an ace, then the chances of the next card on the deck being an ace are 1 in 47, right? Or sorry, 3 in 47 in this case. Yeah, this is sort of, I think, touching upon the idea that probability is really about information. Like if you had the information about what the other people at the table were holding, that would obviously change your probabilities. But typically you're not entitled to that information. You don't have that information available to you. Yeah, you might as well think of everybody else's hands as just being a pair of cards that are all in the deck. They're in the deck.